have stopped over here. So we have talked about how source to low level translation is happening, and we also showed the steps of compiler. So please remember, actually, whenever we are writing code in high level languages like C, C++, we write the source code. But the machine does not actually run the source code. Through compilation steps, it becomes some sort of low-level stuff. For example, in Windows, it becomes .exe file. In Linux-like operating systems, it becomes a.out files. Those are actually running by the machine, not the source code. So our compiler task is to convert this C++ high-level source code to low-level stuff. Then we talk about how this source to low level translation happening. We are actually given high level languages or source code. So at the very first step, which is called preprocessor, it actually convert the high level language to pure high level language. So what is the difference between high level language and the pure high level languages? So for example, if you see any C++ code, you are going to see at the very top, we have something like this, hash include iostream or hash define pi. Those kind of things are there. Those are called actually preprocessor macro. Sometimes these are called preprocessors. Sometimes those are called macros. So actually, what are those? Those are actually pointing to, for example, when we are given this instruction, hash include iostream, actually, this line instructs the source code to link to some sort of file called iostream. Okay, so that we can use iostream functionalities like cout, scene, those stuffs. But before actually doing more stuffs in the compilation step, we actually need to convert those directives to real actual files. So there are somewhere the definition of iostreams there. Those big files are incorporated. It is like inline. We have pointing to a file before it. Now the whole file is incorporated to our source code. Now this way the high level language convert to pure high level language. Then we pass this pure high level language to compilation step. After compilation step, it converts to assembly code or some sort of low level stuff, low level language. Okay. After that one, this assembly code or low level language passed to loader. This low level stuff or assembly code can be kind of two types: absolute assembly or relocatable assembly. At the very beginning of the history of languages, people use absolute assembly, but now they use actually relocatable assembly. So that is not depend on the particular address of the machine, but if you give some starting point and some sort of offset, it will work. Then it is the task of the loader to load this assembly code or low-level language to the machine from particular starting point, and it occupies from particular starting point, and then it occupies some offset below this. After that one, it converts to machine level code, then it is finally passed to linker. It might happen we have a lot of separate files for our code, like 1, 2, and 3. They as a together constitute the whole code. So it is the task of the linker to join, merge this all 3 files and create the target language. So this is the step followed for source to low level translation. In our course, we are actually dealing with this part, the compiler steps, and we are going to break down more this one. So though I have shown here, it is a single module, but it is not actually a single module. This one can be subdivided to many other modules. So let's go to next one. So here we are showing all the sub-modules of the compiler. So what is the input of the compiler? Pure HLL. And what is the output of the compiler? Assembly code or some sort of low-level language. So see, at the very beginning, actually we are given pure HLL, and at the very end we are getting assembly code or some sort of low level language. And what is the first step of the compiler? That is called lexical analyzer or tokenizer. So it converts pure high level language to stream of tokens. Then this stream of tokens is passed to syntax analyzer or parser. Then it creates some sort of parse tree. Then this parse tree is fed to semantic analyzer. Then it creates abstract parse tree, or it is also called abstract syntax tree. Then this one is passed to ICG or intermediate code generation. Then intermediate code generation created some sort of intermediate code. One of the very popular intermediate code is called 3-address code. Then this intermediate code passed to optimizer for some sort of optimization. Finally, we get optimized code. Then it is passing to code generator or assembler. And finally, we get the assembly code or some sort of low-level language. So this is the actual steps of compilation. Now, for these steps, we have two helping hands. First one is called symbol. It is not called tree, it is called symbol table actually. We have one helping hand, it is called symbol table, which actually incorporates to all the modules, and it always fits some information to and from these modules and helping these modules to act correctly. We have another helping hand module, which is called error handler, and you already understood that as it names error handler, it actually incorporates with the error handler. Whenever you are running a code in C++ compiler, you would get lot of errors, like at this line this is missing, like semicolon is missing, or at this line the name is not the type is not properly resolved. Those kind of error handling is happening through this error handler mode. So we have stopped up to this in the previous lesson at the very beginning. Do you have any question? You can ask.
Sir, it's a question আছে স্যার।
Please go ahead.
স্যার একদম লিঙ্কারের থেকে যেই টার্গেট ল্যাঙ্গুয়েজটা বের হচ্ছে,
জি,
ওইটাকে কিভাবে ইন্টারপ্রেট করে, মানে ওটা
ফর এক্সাম্পল এটা মানে কি, টার্গেট ল্যাঙ্গুয়েজ ইজ নাথিং বাট exe ফাইল, রাইট? টার্গেট ল্যাঙ্গুয়েজ ইজ executable file. For Windows it is executable file, right?
Right.
So can you ever try to open the executable file? You cannot open.
মানে এটা বেসিক্যালি একটা বাইনারি ফাইল স্যার।
It is a binary file. Yes, it is a binary file, but it is also encrypted. You need some sort of special tools to actually open this kind of files. Sometimes you can, but it is a binary file, and it is actually responsibility of the operating system to run this file. It is not the responsibility of the any kind of user-defined modules to run this file. Operating system take this file, and this kind of exe file has some sort of format. Those formats are very familiar to operating system. For example, there are very two famous format. One is called COF, C-O-F-F format. Another one is called ELF format. Most probably ELF format is used by actually the Windows operating system, and most probably, I'm not sure, C-O-F-F format is used by the Linux operating system. So these executable files actually have some special format, and that is the job of the operating system to run those, because those formats are very clear. Actually inside those files there are memory registers, allocation procedures, instructions, addresses, those are given, but the format is different, and that format can only read by the operating system. Is that answer your question?
বুঝতে পারছি স্যার। সো এই টার্গেট ল্যাঙ্গুয়েজটাই ডাইরেক্ট ওএস রান করতে পারে।
A target language is directly run by the OS, but actually if you don't have your own operating system, and if you don't mention a particular format, and if your compiler does not convert to your format, your operating system cannot run. That's why if you send an exe file to another Windows user, they can run actually that exe file, because that format is everywhere universal to Windows operating system. But if you want to run a exe file to Linux operating machine, as the format is different, a Linux operating machine cannot run that exe file. Okay, same way happens for the Linux Linux, this kind of binary files as well. .a out can be run by any Linux operating system, any operating system in the world. But if you try to run this format file, this binary formatted file to Windows operating system, you cannot run. Is it clear?
বুঝতে পেরেছি স্যার। স্যার
Okay, so
লিনাক্সের মধ্যে ওয়াইন দিয়ে এক্সিকিউটেবল ফাইলগুলো রান করতে পারি। ওয়াইন ওয়াইন কি করতেছে স্যার?
WIN.
WINE।
Most I don't familiar with that format. I don't know whether it is a Linux format or not. If it is a Linux format, you need specific tool, then you can run that. Okay.
স্যার ওটা এমুলেটর হিসেবে কাজ করে স্যার।
হ্যাঁ, emulator হিসেবে কাজ করে, right? Okay. Should we continue?
জি স্যার।
Okay. So today we'll start from steps of compiler. We are going to give an example how these steps are going on. Okay. So let's start. So there is a big similarity how a human infant learn the language and how we can make understand a computer language. I'm a proud father of a daughter. So she is actually 6 months old. I'm observing her very carefully. And what I have observed, I'm going to share with you. There's a big similarity between how human beings start learning the language and how we can make machine understand a particular language. So let's take an example of human being. So let's take this. So and okay, so 0 to 1 month. Do you know 0 to 1 month human infants are called what? Do you have any idea? What are they called? They are called new natal. So she's a new natal. Let's assume like this. So what are they doing? Do you have any idea? What are they doing, new natal?
স্যার বুঝতে পারিনি, কোশ্চেনটা একবার বলবেন?
What new natal are doing? Do you have any idea?
Mostly observing the surroundings.
And nursing, and what else? Sleep, and they make some sort of unmeaningful sounds. The unmeaningful sounds like G, G, up, ba, ma. Very simple sounds. And you can consider those are like
they're displaying patterns.
They are actually not displaying any
Like
kind of
vocal?
pattern. Those are, yes, those are
Okay.
actually, those are like actually kind of syllables they're trying to actually mimic. The most frequent syllable,
Yeah.
they actually listen from their parents and the surroundings. They try to mimic that. It is nothing but actually kind of learning state. They're trying to learn in something. But it is like
Yes, yes.
gar, bab, ab, ma. When they are happy,
Meaningless.
they're meaningless,
Incomplete.
but not completely meaningless, because as we don't understand the neonatal language, but I have observed they always actually they always sound the most frequent syllables. They actually listen from surroundings. Okay, then
Yeah.
when they are getting 2 to 5 months, they start actually uttering some words.
Word.
and very simple words like ma, baba, ba. Now actually baba is a very difficult one. Bab, ab, abu, amu, those kind of things. But those are not actually completely meaningless. Now we can understand actually they are mentioning about their mom. Now we also understand they are actually mentioning about their father. And then sometimes they also say khabo, khabo, those kind of words. So those are not completely meaningless like neonatal. That time
We can say they're keywords.
we can understand their keywords, right? Ma, bab, abbu, ammu. So we understand. Ota,
Yeah.
ota. That means they are mentioning something. Okay, so that is the 2 to 5 months infant. That time we call them infants soundings. When they are getting more mature, like 6 months to like 8 months, 6 months to 8 months, we understand their words. That time we call them baby, or sometimes we call them toddler because they can toddle. So that time they can actually utter full words, like let's say apple, orange, this kind of things. I might be a little bit hasty about teaching the baby language, but let's take it a correct answer. Maybe it might delay. Some babies are more earlier, some babies are actually later. I'm taking a smarter baby, that's why most probably I'm a little bit early. Most probably they start uttering these words, apple, orange, much later. But consider that is true. Okay. Then what happened? When they become 9 months, to 1.5 year, then actually what happened? They can actually convey their message. They can convey their message like this: I go, then he eat. There might have lot of grammatical mistake. Okay, there might have lot of grammatical mistake. Even the sentence structure might not be correct. Might be they say eat he, go I, those kind of things. But actually we can clearly understand the meaning, what they want to convey. After that one, let's say 1.5 year to 3 year, then they are getting very mature. Then they can almost correctly utter structurally correct sentences, like he go, structurally correct. There might have some sort of problems with for example, he says he go, then she make, those kind of things. Those are not grammatically fully correct, but structurally correct, because here we have the subject, verb, and object. Here also have the subject, verb, something. He make rice, those kind of things. Okay, when he or she start school, then he learns little bit about grammar, then actually so on, then he can or she can make structurally correct sentence, right? He goes to school, or she makes rice. Okay, this is the total learning procedure of human being of a language. Okay, you can actually make an analogy with a machine, that how machine can understand the language. So let's start. At the very step, machine reads character by character. Okay, so you can consider this step, 0 to 1 month step, is nothing but the lexical analysis. That means in this step, the machine reads one character by character, try to make tokens out of it. That is the task of the lexical analyzer. The same way, the neonatal uttering the syllable, lexical analyzer read one character by character. After that one, when the infant becomes 2 to 5 months, he understands that ma, baba, abu, ammu, ota, khabo, those kind of things are a single unit of word. The same way, after lexical analyzer phase, machine can understand actually this is a unit. This is a unit. So no longer we need to study character by character. Now machine is completely understandable about the unit. Okay. So now machine enters in the syntax analyzer phase. After syntax analyzer phase, so this whole procedure is the syntax analyzer phase. After syntax analyzer phase, machine understand the structure of the tokens, that this should be after this or that should be after that one. This way, machine can understand the structure. So after syntax analyzer, it got the idea that this token should be after this token. This token should be after this token. Maybe contextually, those tokens are not correct. The same way, the infant or baby does not know he and she is a third person singular number. So we should put some S over here. We should paste some ES over here. The same way, please remember, syntax analyzer does not understand the context. But when we pass to semantic analyzing phase, then after that one, the machine understands the context, that yes, I should not put this token after that token, or I should not put that token after this token. So then after semantic analyzer, it becomes a structurally and semantically correct execution first. Okay, then we follow other steps of the compilation. Okay, do you have any question? You can ask me. Do you have any question?
না স্যার টোকেন মানে কি স্যার টোকেন
Okay, আমি আসছি. So let's take a very simple example. Let's take x equal to a plus b star c. So let's assume some part of our language we have this statement. So what machine will start in the lexical analyzer phase? What machine will start in lexical analyzer phase? It will start reading character by character. So at first it will read x, then it will read equal, then it will read a, then it will read plus, then it will read b, then it will read star, then it will read c, then it will stop over here. Okay. Now, if you read character by character, x equal to a plus b star c, why should I stop? Why should I get the single unit of something? Here, what is the unit? X is a unit, equal is a unit, a is a unit, plus is a unit, b is a unit, star is a unit, cn is a unit, right? Not whole thing is a unit. X equal to a is not a unit, or x equal to a plus b is not a unit. X is a single entity, equal is a single entity, a is a single entity, plus is a single entity, b is a single entity, star is a single entity, c is a single entity. Am I right?
Yes, sir.
Yes, sir.
ইয়েস স্যার
Yes,
For
sir.
example, in a language, we know the variable names, right? We write lot of times I, we write then nam, then we write nam1, those kind of things. Those are single unit, right?
Yes, sir.
What are those called? Do you know what are those called?
Variable.
No, those are called actually in the compiler terms, those are called identifier.
Okay.
Okay, those are called identifier. So grouping this same kind of things together is called tokenizing. Okay, is it clear to you?
Tokenizing.
Yes, it is called tokenizing. For example, when you write
Okay.
num equal to num1 plus num2, then we actually
Sir, grouping
লেখা কি পড়া যাচ্ছে?
জি স্যার, কিন্তু মাঝে মাঝে একটু ব্লার হয়ে যাচ্ছে স্যার।
মাঝে মাঝে ব্লার হয়ে যাচ্ছে, তাহলে আমি একটু বড়
হ্যাঁ,
করে
স্যার।
বলি। মাঝে মাঝে ব্লার, it is because of the actually because of the bandwidth. It is not the because of বড়
হ্যাঁ
বড়
স্যার,
করে-
এটা স্যার হচ্ছেটা কি, আপনি ধরেন হঠাৎ করে যখন
হ্যাঁ।
চেঞ্জ করছেন তখন একটু তার মানে একটু ব্লার করে, তখন যখন চেঞ্জ করেন আর কি, আদারওয়াইজ ইটস ফাইন।
তাহলে চেঞ্জটা unfrequently করতাম। So let's take this expression. You always write this expression.
হ্যাঁ হ্যাঁ হ্যাঁ
Num equal to num1 plus num2. Okay. So here actually num, it is also a variable name. Num1 is a variable name and num2 is a variable. Num2 is a variable name. So grouping together these units is called tokenization. Is it clear to you?
ওকে।
And what is the name of this token?
Yes.
What is the name of this token?
Like,
Identifier or ID. Identifier or ID. Okay. So after lexical analyzer step, it will say I have ID, num1 and num2.
আচ্ছা।
Is it clear to you?
ওকে স্যার।
Then what else we have?
Operators.
We have operators. So we have operator equal. What else we have? Operator plus. So it tokenize. Tokenize. So if you actually take this line after tokenizer, it will create tokens. So num is an entity, num1 is an entity, and num2 is an entity. So it will group together ID. How many IDs I have? Num1, num2. I have operator equal this one. I have operator plus this one. Is it clear to you?
জি স্যার।
Yes.
Tokenizer কোনটা স্যার?
Tokenizer is the generic name. Tokenizer is the generic name. Identifier. It is the token. It is the token. Operator equal is a token. Operator plus is a token. Okay? The generic name. Yeah, num1 and num2, they have a generic name, which is nothing but ID or identifier. That is called token.
Okay sir.
স্যার বেসিক্যালি টোকেনাইজার স্ট্রিংটা পড়ে
স্ট্রিংটা পড়ে না, ক্যারেক্টার বাই ক্যারেক্টার পড়ে। এটাই হচ্ছে কথা, এটাই হচ্ছে পার্থক্যটা। আমরা ইনফ্যান্টের এক্সাম্পলটা দিয়েছি। প্রথমে স্ট্রিং পড়তে পারে না, ইট ক্যান নট রিড টোকেন স্ট্রিং বাই টোকেন, ইট ক্যান নট রিড স্ট্রিং। এট ফার্স্ট ইট রিড ক্যারেক্টার বাই ক্যারেক্টার।
আচ্ছা আচ্ছা, ওটা পড়ে এটাকে গ্রুপ করে ফেলে।
এটা গ্রুপ করে ফেলে, তাহলে সে পড়বে কি এম ইউ এম, তারপর somehow he understand equal sign is there, so we should not continue. So num, it becomes num should be put inside ID token, then equal, then next he read and he understand this is actually unit, so it puts operator equal, then it again start reading and u m plus, then plus, there is a plus, somehow it understand I got my unit. So it is num2. What type of token is this? ID. So it puts over there. Then it reads plus. It understand. Then it reads and it understand plus is actually a token. So it puts operator plus. Then it start reading and you have to stop over here. Then it understand num2 is another ID. It put over there. Is it clear to you?
জি স্যার।
Sir, I have a
Please go
question.
ahead.
Sir, ID আর অপারেটর গুলো দেখে আমরা তো বলতে পারবো না যে এক্সপ্রেশনটা কি,
আসছি।
num1
I am going to clarify that one. I am going to clarify that one.
Or now.
Don't worry, I'm going to clarify that one. কিভাবে how it would happen, I'm going to clarify. But the procedure is clear to you,
Yes,
right?
yes sir.
So if I take
Yes, sir.
this statement, x equal to a plus b star c. So how many tokens are there? I have ID, I have operator equal, and I have operator plus I have operator star. So after lexical analysis step, what would be the IDs? X, A, B, and C. Operator equal, I have one instance. Operator plus, I have one equals. Operator star, I have. Is it clear to you?
স্যার অপারেটরের ইনস্ট্যান্সগুলো মানে লোকেশনটা কি স্টোর করে?
না
কত
না না কোনো ওইসব কিছু হয় না।
ও জাস্ট ইনস্ট্যান্স কয়টা এটা নোট করে?
আচ্ছা, এটা আপনি একটু ইয়াতে যাচ্ছেন, ইনস্ট্যান্স কতটা, এটা উই ডু নট নিড টু রিমেম্বার। এই ইনফরমেশন গুলো স্টোর থাকে সিম্বল টেবিল। সিম্বল টেবিলটা একটু জটিল। সিম্বল টেবিলটা এইরকম করে যে আপনার মূলটা যেতে চাচ্ছে। আচ্ছা, সিম্বল টেবিলে হচ্ছে কি এইভাবে এন্ট্রি তৈরি হয়, আইডি দেন অপারেটর ইকুয়াল।
দেখা যাচ্ছে না,
দেখা যাচ্ছে না,
এখন
নিচে
ঠিক
চলে
আছে?
গিয়েছে। আচ্ছা,
দেখ নাও।
জি স্যার।
ঠিক
ঠিক
আছে,
আছে, স্যার।
আমি এখন একদম আপনারা ফর্মালটাই যেতে চাচ্ছেন, ঠিক আছে, ফর্মালটা বলছি। সিম্বল টেবিলে there would be a place created for ID because token ID is there, then operator equal is there, so operator equal entry would be created, operator plus would be created, and operator star would be created. Okay, then
জি স্যার।
they do this thing. This one is pointing to this one also pointing to this one pointing to this one pointing to this. Equal would be pointing to this one pointing to this, and this one pointing to this. Just this one is happening.
বুঝতে পেরেছি।
Remember, symbol table initially, after lexical analysis step, this is the status of the symbol table. As you go deeper and deeper inside the actually compilation step, we are making lot of makeup of this symbol table. Lot of more entries would be added in the symbol table. Symbol table is very dynamic data structure. Okay, it always changing. But at the very initial step after lexical analysis, this is the status of the symbol table. It would happen. Is it clear to you?
জি
Okay. এখন, please remember,
Yes, sir.
reading is actually happening character by character. Now, only reading character by character, how can actually compiler understand what is the unit? Do you have any idea?
Come again?
The procedure, the reading is character by character, but how compiler will understand actually X is a unit? How compiler will understand?
দেখা যাচ্ছে না।
This is my expression though. This is my expression, X equal to A plus B star C. So how actually compiler understand I have to stop over here? It is a single unit. How can actually compiler understand? Do you have any idea? Why don't we read X equal up to X equal? Why we stop over here? Do you have any
স্যার,
idea?
আমাদের কি এটা এক্সপ্লিসিটলি ডিফাইন করে দিতে হবে?
এক্সপ্লিসিটলি ডিফাইন করলে কতগুলো ডিফাইন করবেন আপনি তো নতুন ভেরিয়েবল নেম বানাতে পারেন। যারা কতটা ভেরিয়েবল নেম বানানো সম্ভব? বিজয় ইজ এ ভেরিয়েবল। বিজয় ইজ এ wonderful answer. I got my answer. But let me answer his question first. So if you explicitly define only Vijay, Vijay1, Vijay2, Vijay3, Vijay4, Vijay5, Vijay6 up to Vijay10 is my variable names. You cannot use any more variable names. Then what happened? Your functionality of the language would be very less.
Yes,
You
sir.
cannot use more than 10. In that case,
regular expression use করতে হবে।
regular expression we should use. Fantastic. So regular expression is a powerful tool which is nothing but another expression of finite automata. And using regular expression, regular expression is nothing but a pattern. We are giving this pattern. So in lexical analyzer, we give some sort of regular expression, and this regular expression is actually nothing but pattern. Using that pattern, computer understand actually that, okay, fine, I have to stop over there. And also in the regular expression, we define what type of pattern is this. Using that word, symbol table understand, okay, fine, this is actually ID and that should be the pattern. Whenever that pattern matches, it understand it is actually this kind of token. Is it clear to you?
Yes, sir.
For example, if I give ID is equal to letter followed by any letter or digit, any number of letter or digit. If I give this pattern, okay, then what happened? It start reading from this character, what
So
it get at the very beginning, character by character, what it get?
A letter.
A letter. Then what it get?
It's nothing. A white
digit.
space.
No, equal.
Operator.
Not operator, equal. Operator এখন আসে নাই. Equal. So is it, so letter, I match first letter. Then what else I get? Equal. Equal is not there, right?
পেপারটা একটু রাইট নেবেন স্যার স্যার সরি
বুঝি না।
স্যার পেপারটা একটু রাইট নেবেন তার মানে দেখা যাচ্ছে না লেফটের পার্টটা দেখা যাচ্ছে না আমার হ্যাঁ গুড এনাফ স্যার
So
Thank you.
if I give this, okay, if they give this pattern, ID is equal to L followed by any number of letter or digit. It must start with letter, then it follows with any number of letter or digit. Then what happened? It will start reading from here. It reads X. Am I right?
Yes,
X.
sir.
Then it will try to read equal. Okay?
Yes,
Does
sir.
equal belongs to L plus D?
না স্যার,
No,
Okay.
sir.
Then what happened?
না
তাহলে প্যাটার্ন এন্ডস।
Pattern ends, but X belongs to this pattern. Am I right? Because it is
Yes, sir.
star.
Yes,
Because
sir.
it can be also epsilon. Am I right? Nothing
sir.
could be
Yes,
there.
sir.
Right.
Right? So letter match. So it matches the pattern. Then it understand. I got my first ID, which is nothing but X. Did you get it?
জি স্যার।
Then
Yes, sir.
Yes,
I
sir.
also give another regular expression. For example, operator equal, which is nothing but whenever I get this character, right? Then it matches this equal, right? Then it does it go? No. So it will stop. It will say operator equal to equal. Then it start reading A. I get letter. Okay. Then what next? Plus. Plus belongs to this.
না,
No. So I should stop. I get another ID A. Then let's give another regular expression. Operator plus is nothing but plus. So it reads plus. So it gets operator plus is nothing but plus. Okay. Then it reads B. Again, it gets another ID B. Then it gets star. I give another regular expression. Operator star is nothing but star. Then it get operator star is star. And then it reads C. C is a ID. We are done. Is the process clear to you?
জি স্যার।
But this bookkeeping is not happening in this way. This bookkeeping is happening in the symbol table like this. ID, operator equal,
আবার
operator
দেখা
plus,
যাচ্ছে না স্যার।
ID, operator equal, operator plus, operator star, and we got the expression A plus B star C, and they're pointing to this.
এটা হচ্ছে স্যার লেক্সিক্যাল অ্যানালাইজারের আউটপুট।
Lexical analyzer out. It is a lexical analyzer out. Is it clear to you?
জি স্যার।
And this bookkeeping happened in the symbol table this way. Okay, guys?
জি স্যার।
So in the lexical analyzer phase, let's go back to previous slide. Lexical analyzer always take help from one kind of thing, which is nothing but what is that called? What is that called? Regular expression. Regex. And what is regular expression? What type of automata is this? What type of automata is regular expression? No.
Context free.
What type of automata is regular expression?
মনে নাই
Very simple one, the most simplest one. What is that?
ফাইনাইট
Finite automata. Firas, Humaira. Firas, Tamira Fairuz. He is sleeping, most probably. You should
Sure.
answer the question. You have taken this course just last semester. Regular expression is what?
Yes, sir.
Finite automata. Okay. So we are done with regular expression. After we are done with the lexical analysis part, it takes help from regular expression and then it creates actually
সিনট্যাক্স টেবিল
it creates stream of tokens. আচ্ছা এখানে দুটো ওয়ার্ড আপনারা সবসময় you people always listen. One is called token, another one is called lexeme. One is called token, another one is called lexeme. What is the difference between token and lexeme? ID is a token and operator equal is a token, and any instance of the token is called lexeme. So what is the in this expression what are the lexemes?
X A B
So
C.
ID has lexeme
Right.
X A B C. Operator equal is equal, operator plus is plus, operator star is star. So the generic name is called token, generic name, and instance are called lexeme. Okay guys, is it clear to you? Generic name is called token, and instance is called lexeme. So ID is a token and their instance like X, A, B, C, they are called lexeme. Operator equal is a token, its instance equal is a lexeme. Operator plus is a token, its instance plus is a lexeme. Operator star is a token, lexeme is star. The generic name is the token and any instance of that token is called lexeme. Okay? So we are done with lexical analysis step. After lexical analysis step, we get stream of tokens.
স্যার একটা
Yes,
কোয়েশ্চেন স্যার
this.
স্যার একটু ওই স্ট্রিংটাতে যান স্যার অরিজিনাল স্ট্রিংটা উপরে
Hello. Original কোনটা?
ওই যে এক্স ইকুয়ালস এ হ্যাঁ এখানটার মধ্যে তো প্লাসের একটা ইনস্ট্যান্স আছে
হ্যাঁ।
সো এখানে যদি বি এর পরে স্টার্ট না হয়ে যদি বি এর পরে যদি প্লাস থাকতো তাহলে তাহলে কি হতো স্যার
এই যে
তাহলে কি
সিম্বল টেবিলে অপারেটর প্লাসের পয়েন্টিংটা হইতো এটাতে অপারেটর প্লাস ইজ গোইং টু অলসো পয়েন্টিং টু হিয়ার
ওটা বুঝতে পেরেছি বাট এই যে আপনার টোকেন আর লেক্সিম বেসিক্যালি এখানটার মধ্যে কি অপারেটর প্লাসে দুইটা থাকতো লেক্সিম
না দুটো থাকতো না, এটা কাউন্ট করে না। জাস্ট রিমেম্বার টোকেন সিম্বল টেবিলটা হচ্ছে আসল, এটা হচ্ছে রিয়েল পিকচার। দিস ইজ দ্য রিয়েল পিকচার। রিয়েল পিকচার keep maintaining the name of the token, and from token name to particular lexeme there is a pointer. That is all. That is the real picture.
তাহলে স্যার দুইটা প্লাস থাকলে দুইটা পয়েন্টার থাকবে।
হ্যাঁ আপনি বলতে পারেন যে এখানে দুইটা প্লাস দুইটা পয়েন্টার থাকতো, রাইট, দুইটা পয়েন্টার থাকতো। So all the token names would be tabulated once, but if there are multiple instances of that token, that means if there are multiple lexemes present for particular token, there will be multiple pointer.
Multiple pointer.
Okay. Done?
সিনট্যাক্স টেবিল না এটার নাম
হচ্ছে গিয়ে সিম্বল টেবিল। Should we continue?
Yes, sir.
Yes, sir.
Yes, sir.
Acha, so we got the stream of tokens. After getting stream of tokens, what is the next step? We pass it to syntax analyzer or parser. Now, let's go to parser step. So what is the input of the parser? What is the input of parser? Stream of
Token.
tokens. And what is the output of parser? Syntax tree. In this phase, that means parser is also going to take help of another finite automata, which is nothing but push down automata or context free grammar, CFG. It takes help from CFG or push down automata. So what is context free grammar? We are going to dealing with much details with context free grammar, don't worry. But we know already a little bit about context free grammar. So context free grammar is nothing but CFG is nothing but it has quadruples, VTPS, variable, terminals, products, and stars. I know actually how to parse this statement. And I'm going to write the grammar. So please don't worry. Later we will learn details how to write this grammar. So this grammar would be something like this. This grammar would be ID. I'm writing the grammar. So don't question how did I write that one, because we are going to later learn how to write those grammars. ID E ID equal to let's call it start state. Start is nothing but ID equal to expression. Expression is nothing but expression plus term or term. Term is nothing but term star M or M. M is nothing but ID. Right now, just remember this is the correct grammar for parsing this statement or expression. Then what would happen? Using this grammar, parser trying to create a parse tree. And what would be the parse tree? The parse tree would be like this. S ID equal to E. E would be nothing but E plus T. T would be nothing but T star M. E would be nothing but T. E would be nothing but M. M is nothing but ID. Then T is nothing but M. M is nothing but ID. M is nothing but ID. Now if I replace this ID with X, this one with A, this one with B, and this one with C. If I replace this way, now if you traverse this syntax tree, from top to down, left to right, what you get actually? What you get? You only consider the terminals, not variables. I get X, then I get equal X, I get X, then I get equal, then I get only the terminals. A
plus
plus
B star C.
B, top to down, left to right. X, first terminal I get, then I get equal, then I get A, then I get plus, then I get B, then I get star, then I get C. I'm done. And is it the expression I'm working with?
Yes, sir, it is.
Yes. So using this grammar,
স্যার
using this grammar,
একটু জুম আউট করলে মনে হয় স্যার ক্লিয়ারলি দেখা যাবে আর কি স্যার।
ডিম আউট করবো।
স্যার জুম আউট করলে স্যার মনে হয়
কোয়ালিটি লস হবে তখন। এটা ব্যান্ডউইথের কারণে কিছু মানে স্যার এটা রেকর্ডেড না স্যার?
Is the signal? It is recorded. Yes. Are you getting fade away or
স্যার একটু ব্লার আসছে।
blur because of the
পিক্সেলেটেড আসছে স্যার। স্যার পিক্সেল এর আসতেছে স্যার,
পিক্সেল আসলে এটা
কোয়ালিটি
কিছু
লস
হবে না।
হচ্ছে।
হ্যাঁ, কোয়ালিটি লসের এটা
Ex-
জুম ইন জুম আউটে কিছু হবে না, তারপরে আমি দেখতে পারি
এক্স্যাক্টলি।
এটা হবে না কিছু। হ্যাঁ কি বেটার?
হ্যাঁ
বেটার
স্যার।
জি স্যার, বেটার স্যার।
দ্যাটস বেটার।
লেখাপড়া যায়।
হ্যাঁ হ্যাঁ স্যার।
Acha. So let's go back. So we have to face these problems. So using this grammar, if we create this parse tree, actually the yield, that means the output of this parse tree is nothing but x equal to a plus b star c, which is the expression we are working with. Am I right? Which is the expression we are working with.
Yes,
So
sir.
definitely using this grammar, we can create this parse tree which yields the desired expression. All right, guys. And this parse tree is the output of the parse tree. Okay, done. And throughout the whole course, 90% time we are dealing with this. How can we generate this parse tree? That is the main aim of this course. That's what we are looking for. Okay, guys. That is the most important part of the compiler. How can we do that? First of all, we need to know how to write good grammars. Grammar has a lot of facets. Writing this kind of grammar is the one of the fundamental part of this course. So after learning how can we write this kind of grammars, then we need to know how we can make machine to create this kind of parse tree. You might think, sir, creating this parse tree from this grammar is very easy. No, it is not very easy. Even for human being, it is very difficult. I have solved this problem 10-15 times. That's why it is very easy for me. But if you want to make machine to create this kind of parse tree, it would be hell and it would be very difficult because there are a lot of options in this grammar. In fact, the strings generated by this grammar is infinite. Out of this infinite string, you are trying to create a particular string. That time you have to very carefully choose when to use which rule and how to use that rule. So we have to direct the machine or the compiler in such a way so that it can create the desired expression. Moreover, nothing like that. Right now I have given this expression. Some people might come up with another different expression, which can also created by this grammar. Then what happened? You need to create a very general procedure to create this kind of yields. And that is the main goal of this course. Are you people got it or not?
Yes, sir.
So
Yes,
this
sir.
is the output of the parser, and throughout 90% of time we are trying to implement machine this kind of, so that machine can automatically implement this kind of parse tree. Got it?
Yes, sir.
Okay, now let's go to next phase. What is the next phase? What is the next phase? What is the next phase?
Semantic analyzer.
Semantic analyzer. So what is semantic analyzer? What is the input of semantic analyzer?
parse tree.
Parse tree. And what is the output of semantic analyzer? Abstract syntax tree.
Parse.
Abstract parse tree or abstract syntax tree. So it is like the phase whenever in the parse tree, you can analogy with the baby. In the parse tree, baby can actually make structurally correct sentence like he go to school. But that is not absolutely correct. Am I right? What is wrong here? He go to school?
goes হবে.
He goes. Third person single number should be goes. The same way, parse tree can create structurally correct output, but its meaning, that means contextual meaning, might be wrong. Can you give me an example of the language construct? What would be that? Where structure is correct, but actually semantically the expression or statement is wrong. Can you give me an example? For example, if I take this one, x equal to a plus b star c, after syntax analyzer, it creates the correct parse tree. But still, something wrong there. What is that? What is wrong there?
Addition takes place first, I
Huh?
guess.
What happened?
Addition takes place first.
No, that would be resolved. Structure is resolved.
Okay,
Structure is resolved. Addition
Okay.
plus should be before star or star should be before plus. Those would be resolved. We are going to deal with that one. Don't worry. Those would be resolved in the parse tree phase. Don't worry about that one. That the PEMDAS or what is called Bodmas rule is already resolved in the grammar. There is no problem. But still, there might have some problems. What is that? What happened if x is later becomes string a, because it becomes a num id, it becomes an integer, it becomes another character, and it becomes actually a float. All those are actually same category, same token, right? String, integer, character, float. Those are all id. So no problem. So it will pass the tokenizer phase. Then actually parse tree does not consider what is the actual type of x, what is the actual type of a, what is the actual type of b, what is the actual type of c. So it is going to also generate the correct parse tree. But is it actually correct semantically verified statement or not? If it is string, it is integer. If it is string, it is integer, it is character, it is float.
No, sir.
What is wrong with this?
Type errors.
Type error. This kind of type errors is going to be resolved in semantic analysis phase. This kind of type error is going to result in the semantic analysis phase. Did you get it?
Yes, sir.
After that one, we will get abstract syntax tree. This abstract syntax tree is going to pass to where? Which phase? Which phase?
Typing.
What is the next phase?
ICG.
Intermediate code generator.
ICG. And what is the famous ICG?
Okay.
What is ICG?
Tree address code.
ICG is nothing but
Intermediate
intermediate code generation. So it is
code
going to simplify. It is going to simplify the expressions. So what is the input of the ICG? Abstract syntax tree.
Syntax tree.
And what is the output of ICG? Tree address code.
Tree
So
address
what is tree address code? In a tree address code, there would be only 3 constructs. Can you give me an example? In tree address code, there will be only 3 constructs. For example, x equal to 1 plus 2. Is it tree address code?
Tree address কোডটা কি স্যার? এটা আগে বলুন।
Only 3 constructs or variables or numbers. So how many variables or numbers in this expression? 1, 2, 3.
3.
It is 3 at this point. How about this? X equal to a plus 2. How many variables or numbers are there? 1, 2, 3. It is a 3 at this point. Now let's go to this expression. How many variables or numbers are there? 1, 2, 3, 4. So it is not a
Tree address code.
3 at this point. So in intermediate generation, in the intermediate code generation, when we use tree address code, all the big constructs are going to subdivided to simpler construct. Okay, why we are going to do that one, I'm going to later tell you. But this is not actually tree address code. Can we convert this to tree address code? Is it possible? Maybe. Okay, let's try this one. Let's assume T1 is equal to B star C, then T2 equal to A plus T1, and finally x is equal to t2. Is it 3 address code?
দুইটাই
এখানে না সর্বোচ্চ ম্যাক্সিমাম 3 ম্যাক্সিমাম এখানে আমার একটু ভুল হয়েছে would be maximum. How many constructs are there? 1 2 3. So it is a 3 address code. How about this? How many constructs are there? 1 2 3. 3 address code. How many constructs are there? 1 2. Less than 3. So it is
2.
also 3 address code. So altogether they are a 3 address code, right? Now x equal to t2. What is x equal to t2? T2 is nothing but a plus t1. So x equal to a plus t1. What is t1? T1 is nothing but b star c. So x is nothing but a plus b star c. So this expression is nothing but this expression. Do you agree with me or not?
Yes, sir.
So this expression, if we divide it to this 3 expression, then it is actually a 3 address code of this expression. Do you agree with me or not?
Yes, sir.
All together, we have to take care of all these 3 statements, right?
Yes, sir.
Okay, done. So after ICG, we are going to break the complicated expressions into simpler expressions. Then what is the next module? What is the next module?
Optimizer.
Optimization.
In the optimizer phase, we pass the 3 address code. In the optimizer phase, we pass the 3 address code and we are trying to minimize the expression. Is it possible to minimize here? Is it possible to minimize here? Instead of 3 expression, is it possible to create only 2 expression?
জি স্যার
Possible. 3 address code, 2 expression. Here, 3 address code, 3 expression. Is it possible to create 3 address code, 2 expression? Possible?
জি স্যার টি
How?
স্যার
কিভাবে?
টি2 কে x বলে দিলেই হচ্ছে
Wonderful. So T1 is equal to B star C and X is nothing but A plus T1. We reduce this one, we delete this one, and still it is a 3 address code, but we have less number of expressions. Done? So that is the part of optimizer. What is the last phase? Assembler or target code generator. We pass this optimizer 3 address code and we are going to create what? Assembly code. Now, what is assembly code? Can you tell me? Do you have any idea about assembly code?
স্যার অপটিমাইজার কি আউটপুট করছে
এই যে expression, it reduce the expression if it can.
so reduced 3 address codes
Reduce not 3 address code, it reduce the expression in the 3 address code.
So if we have like 5 expressions, we're reducing it to 3.
If we can.
Something like that.
If we can.
If we can. Yeah,
But
if
we have to
can.
maintain
so that's
the
like
3 address code.
optimization step.
Optimization, but we have to keep maintaining the 3 address code. If somehow, if we reduce the expression,
Like
then
right
we
now,
break out from the, if we break out from the 3 address code, it would not work. Okay, because in this real expression, it is not a 3 address code, but there is only 1 expression. Am I right? You cannot do that one.
Yes, sir.
You keep remember 3 address code, but you are reducing the expression. If it is possible, then optimized code would come. Sometimes it might happen, you cannot create any optimized code. It might also happen.
এত অপটিমাইজড কোড লিখছে স্যার কোনো অপটিমাইজেশনই দরকার নেই
I don't understand. What happened?
স্যার বললাম এত অপটিমাইজড কোড লিখেছে মানে ওটার অপটিমাইজেশনের প্রয়োজন নেই
No, you are not right actually. Still, it is a good question actually. You cannot even understand. You think that you always write optimized code, so we do not need optimizer. Trust me, each level, so many optimization is happening inside the compiler, and it fasts your process. Even the modern compiler is so smart. If you write very jumbled and very ugly code, still compiler can optimize it. Trust me, trust me.
শুনছো শঙ্কুর
হ্যাঁ, I know.
Okay, so let's go back to that. Now, আপনি এখন হচ্ছে the big question. Yes, sir. অতটুকু তো বুঝলাম semantic analyzer পর্যন্ত. I understand up to semantic analyzer. No problem about that. Why suddenly you create 3 underscore? What is the facility about 3 underscore? Why don't we try to convert semantically verified code directly to the binary code? What is wrong with that one? That is the $1 million question. Am I right?
মিলিয়ন
It's a $1 million question. Why we created 3 underscore? What is the benefit of 3 underscore? Am I right?
Yes, sir. Like why? Why three? Why the number 3?
Why the number 3? Okay. Did you ever see any assembly code?
Yes,
Yes.
sir. At DC.
At
Multiple.
Load store.
there is a subtlety in the assembly code. Tell me, what is the subtlety in the assembly
ও
code?
অ্যাসেম্বলি কোড
Assembly code is a 3 underscore.
Operation, operand, and operator.
Assembly code is a 3 underscore. For example, add x comma
Genius.
3. It is a 3 underscore.
Yeah.
At best, 3 underscore. And moreover, not only that, all these optimized 3 address code has a 1-to-1 mapping to address at assembly code. I'm going to show you. How can you express this expression using assembly code? For example, at
He
first we
wanted
create
us to
3
add B.
See, wait. At first, let's put this value A, B, C in a register, move R1 in A, move R2 B, move R3 C. Then what is this address? What would be the assembly code instruction for this? Simple. Mal R2 R3. Direct mapping. Then what would be this?
Add.
Add R1 R2. Okay? And what would be this? আমরা আরেকটা রেজিস্টার নেই, move R, X. And what would be this? This one has direct mapping as well. And what is the last one? This is nothing but add. Now move R, R1. Done. We get direct mapping from 3 address code to assembly code. Now we have created our assembly code. That's why we use the assembly code. Each 3 address code has direct mapping to particular assembly instruction. Then we get the final assembly code. We are done with our compilation step. That's why we simplified. That's why we have created the 3 address code. Did you get it?
স্যার অপটিমাইজার কি কম্পাইলারের লাস্ট স্টেপ?
অপটিমাইজার কম্পাইলারের লাস্ট স্টেপ না, টার্গেট কোড জেনারেশনটা লাস্ট স্টেপ, যখন অ্যাসেম্বলি কোডটা ক্রিয়েট করে সেটা লাস্ট স্টেপ।
আচ্ছা স্যার,
অপটিমাইজারের পর কি হচ্ছে স্যার, একটু ফ্লোটা একটু
অ্যাসেম্বলার অথবা টার্গেট কোড, প্রত্যেকটা 3 অ্যাড্রেস কোড অ্যাসেম্বলি কোডের ইনস্ট্রাকশনে ম্যাপিং হয়ে একটা করে অ্যাসেম্বলি কোড অ্যাসেম্বলি ইনস্ট্রাকশন জেনারেট করতেছে।
স্যার
ইয়েস প্লিজ।
যে এই কোর্সের প্রজেক্টটা করব, তো আমাদের কি পুরো অ্যাসেম্বলি
না আপনারা হচ্ছে কি এইগুলা এইসব স্টেপের মধ্যে দিয়ে যাবেনই না। আপনারা লেক্স এবং ইয়াক ব্যবহার করবেন। তো লেক্স এবং ইয়াককে বলা হয় কোড জেনারেটর। কোড জেনারেটর আপনাদের হয়ে এই কাজগুলো করে দেবে।
নাম বলবেন?
আমরা যখন ইয়া নিয়ে আলোচনা করব, whenever we start project we'll deal much. And we are also going to give some example. Don't worry. I'm going to write some code in Lex and Yak. I'm also going to write some code in C++. Then you people will understand. And moreover, আমাদের প্রজেক্ট এই অপটিমাইজার পার্ট থেকে অ্যাসেম্বলি কোড জেনারেটর পর্যন্ত থাকবেই না, ওইটুকু থাকবেই না। ঠিক আছে? এটাকে বলা হয় এখান থেকে এতটুকু, এই পার্ট থেকে এইটুকুকে বলা হয় ব্যাকএন্ড। ব্যাকএন্ডের কাজ আমরা করব না। আমাদের কাজ হবে our project would be only on front end up to this. আমাদের কাজ অনলি অন ফ্রন্ট এন্ড নিয়ে কাজ করবে, ব্যাক এন্ড নিয়ে না। এখান থেকে এতটুকু হচ্ছে গিয়ে ব্যাক এন্ড। ব্যাকএন্ডের কাজ না, আমাদের কাজ হবে ফ্রন্ট এন্ডের। ব্যাকএন্ডের কাজ খুব ডিফিকাল্ট। গট ইট? ডু ইউ হ্যাভ এনি কোশ্চেন?
Yes.
ক্যান আস্ক মি দ্য কোশ্চেন?
No, no, স্যার এখনো তার মানে পড়ে তারপর
আচ্ছা,
কোয়েশ্চেন
so
করতে হবে আর কি, বাসায় আবার
always
পড়ে তারপর
remember,
কোয়েশ্চেন করতে হবে।
why do we
For now
create
it's good enough.
why do we create intermediate code generation? Because each three address code has a one-to-one mapping to assembly code. Then things
Can be mapped.
become very clear. Each address we are going to pick each three address instruction, address code instruction, and mapping to particular assembly instruction. Then we are done with the assembly code. If we don't create intermediate code generation, then converting directly this expression to assembly code would be much difficult. It would be hell. That's why we simplified using three address code, so that there will be a one-to-one. Okay, guys. So let's summarize a little bit. How about the other
Sir,
guys? Why don't?
Again,
Yeah,
so
yes.
তার I don't think
বলেন।
So the question is একটা ডাইনামিকলি টাইপ ল্যাঙ্গুয়েজে
Good, হ্যাঁ।
টাইপ চেকিংটা কোথায় হয় স্যার? ওই যে ইসে
ওগুলাকে বলে ডাক টাইপিং। ডাক টাইপিং ইজ কমপ্লিকেটেড। C++ তো
Okay.
ডাক টাইপিং না, C++ তো ইয়া টাইপিং।
ওকে, তো এটা কোথায় হয় স্যার?
ওটা ডাক টাইপিং এর
স্ট্যাটিকলি টাইপ,
ডাইনামিক টাইপিং আর কি, যেটাকে বলে ডাক টাইপিং। ডাক টাইপিং এর কনসেপ্টটা
হ্যাঁ,
হচ্ছে
হ্যাঁ,
at any instance how a particular object or construct behave, that is the step. Do you understand?
একবার রিপিট করবেন স্যার।
Duck typing or dynamic typing
Yes.
is, it does not assume anything. In C++, for example, in C++,
Okay.
it is static typing language. At the very beginning, we define it should behave like this variable should be integer, and we also fix the space for that integer variable. In the dynamically typed languages like Java, okay, Python, they don't actually assume anything. They, in the process of running, they take any variable, then they try to find out how it behaving. If it behaving like an integer, then it is an integer. If it behaving like a float, it is a float. If it behaving like a object, special type of object, it is a special type of object. That's why, for example, whenever you write a particular line in Java, let's say this line, x equal to a plus b star c, where x is a string, a is a integer, b is a character, and c is a float. In compilation stage, C++ is going to throw you error, because in semantic analysis, it understands you are violating the type checking, right? But in dynamic typing languages like Java or they don't going to throw any error, because they are assuming right now it is undefined, or right now it is string. It might happen dynamically, x might become integer. It might happen the whole variables in the expression become an integer. So it does not assume anything. But when it is trying to run that expression, that time if it finds that something is string and another thing is actually integer, that time it actually throw error.
So runtime error.
Runtime error ta dekha. It is called duck typing. Duck typing means if something is behave like duck and it actually quack like duck, it is a duck. That's why it is called duck typing. That means if a variable in the runtime, it behaves like quack, and it also exhibits the capability of duck, it is a duck. I don't care what is happening beforehand. Beforehand, if you declare it is a string, I don't care. When it is executing, if there is no type error, then it will be fine. Okay, guys? Do you have any more question?
একটা এমনি কোশ্চেন স্যার, জাস্ট ইন টাইম কম্পাইলেশন কিভাবে কাজ করে?
Just in time compilation টা হচ্ছে গিয়ে, for example, it is something like this. Let's assume in your code there are lot of headers, lot of macro files. For example, IOStream, stdlib, those things. So during the compilation times, during the pre-process steps, all those links are actually replaced by the actual definition of the file. Am I right? If you remember, right?
অ্যাকচুয়ালি কি মানে ওই ফাইলের কন্টেন্ট গুলা
ফাইলের কন্টেন্ট গুলাই yes it is added to the source code.
ও
Then compilation start. Okay.
আচ্ছা
In just in time compilation, it does not do that thing. During the compilation step, if it sometimes find I need this file, that time inlining is happening. You understand?
সো লেজি ভাবে করতে
And lazy, yes, is a kind of lazy propagation. Yes, it is a lazy propagation. Any more question? Many people are asking wonderful questions. Why other people are silent? Done? Is there any more question? No?
Not at the moment,
Okay,
sir.
so let's stop here today. We'll start again next class. Okay?
স্যার একটা কোশ্চেন স্যার
Okay, sir.
Yeah.
Sure.
আমাদের আমরা কি কোনো বই ফলো করতেছি
ওই যে কোর্স আউটলাইনটা দেখেন ওখানে বই আছে। ফার্স্টের বইটা রেড ড্রাগন বুক তো খুবই ভালো বই।
ঠিক আছে
ওকে, টেক কেয়ার।
Sir.
কোর্স আউটলাইন কোথায় পাবো স্যার?
Sir, sorry, sir. আপনাকে লাস্ট একটা কোয়েশ্চেন আছে, স্যার।
জি জি
আপনার এই ভিডিও এই যে ভিডিও যে রেকর্ডেড ভিডিওগুলো আপনার সাথে যে ক্লাস হলো, এটা কি
Yes.
পাওয়া যাবে?
পাওয়া যাবে। সব ইউটিউবে একটা চ্যানেল করে আমি এগুলো আপলোড করে দেব। কারণ প্রত্যেকটা ভিডিও সাইজ ইজ 200 মেগাবাইট। Nobody give me this amount of space. Okay. Yes?
Okay, sir.
Okay. I will share. I'm going to share the video link. Okay, don't worry.
Okay. Thank you so much, sir.
Okay. Take care. Bye bye.
Bye bye, sir. Stay safe.
Bye.
বাই বাই স্যার
Bye bye, sir.
Bye bye, guys. I know a lot of you